we discussed question 7 and question 8 for A-Level Mathematics 1, Paper 1, for the year of 2020. Question 7, Part A. You are given an identity, and since the left side is more complicated, we shall start from the left side and try to arrive to the right side, which is 2 over cosine theta. On the left side, you see that you have a fraction here, and in order to add two fractions, you need a common denominator. So in order to arrive at a common denominator, for this first part here, 1 plus sine theta over cosine theta, you need to multiply this by the denominator of the second term. So you multiply both the numerator and denominator by 1 plus sine theta. For the second term, you have cosine theta over 1 plus sine theta, and you need to multiply this second term by the denominator of the first term. So you multiply this by cosine theta over cosine theta. Now, when you multiply the denominator, you have a common denominator in the form of cosine theta times 1 plus sine theta. So for this case here, you have one single denominator, then you just need to simplify the numerator. 1 plus sine theta times 1 plus sine theta. This is actually in the form of a plus b squared, which can be written as a squared plus 2ab plus b squared. So over here, if you have 1 plus sine theta squared, that is given by 1 squared, which is 1, plus 2 sine theta plus the square of sine theta. So for this first part here, you can write in the form of 1 plus 2 sine theta plus sine squared theta. The product of cosine theta and itself is cosine squared theta. Let's look at this part here. Sine squared plus cosine squared. From the Pythagorean identity, that is always 1. Sine squared plus cosine squared is always 1 from the Pythagorean identity. Then you have 1 plus 1, that gives you 2. Then you still have 2 sine theta. In the denominator, your cosine theta and 1 plus sine theta. Let's look at the numerator. You can factor out a 2, and you have 1 plus sine theta, and then the denominator stays. So you have 1 plus sine theta. The common terms here, 1 plus sine theta and 1 plus sine theta, that can be cancelled off, and you are left with 2 over cosine theta, which is the right side. For part B, hence, when you see the word hence, you must use the result from part A. You need to solve this. If you look at this left side here, this left side can be written as 2 over cosine theta from the first part. So this left side is 2 over cosine theta, which you proved just now. And that equals the right side, which is 3 over sine theta. Let's look at this. Your answer theta is in between 0 and 2 pi. So your answer must be in terms of radian. You have sine theta, you can multiply throughout by sine theta for the equation. You actually bring this up. That gives you 2 sine theta over cosine theta equals 3. And then that will give you 2 tangents theta equals 3. Sine over cosine gives you tangent. and dividing throughout by 2, you have tangent theta equals 3/2. Now to solve for theta from 0 to 2 pi, let's look at the ratio here. This is a positive ratio. Tangent is only positive in quadrant 1 and quadrant 3. So your answer theta must be an angle in quadrant 1 or quadrant 3. Find the related acute angle first, which is beta. Beta is given by inverse tangent of 3/2. That should give you a value of 0.983. In the first quadrant, theta is the same as beta, which is 0.983. A third quadrant angle is always pi plus the acute angle. So your solution should be 0.983 or 4.124. Question 8. You are given a semicircle ABC here. That gives you a semicircle. The diameter is given by AC. Center is 0. The radius is 6 centimeters. AO is 6 centimeters. By the same reasoning, OB is also 6 centimeters here. It is also the radius. OC is 6 centimeters as well. So you can see that OC here is also 6 centimeters. The length of the arc AB is 15 centimeters. X is on AB and BX is perpendicular to AX. So you have right triangle OBX. You need to find the perimeter of the shaded region BXC. To find the perimeter of the shaded region, let's look at this. The perimeter here is given by BC plus BX plus XC. That should give you the perimeter of the shaded region. Now let's find BC. We can find the arc length or the circumference for half a circle, subtract by the arc length AB, and that gives the length of BC. So from here, BC is given by the circumference of half a circle. Circumference for half a circle, that is given by pi r here. And then you need to subtract 15. Radius is 6, so you have 6 pi minus 15, and that should give you 3.850. So you have 3.850 for the length of BC. Then the perimeter, you have 3.850, and then you need to add to BX and XC. So let's look at this. BX and XC, as long as you can find the length of OX, then XC will be 6 minus OX, and BX is just one of the sides of the right triangle. You already know the hypotenuse. As long as you can find angle BOX, then you are good. Now let's look at this. For this angle AOB, when you find angle AOB, then pi minus angle AOB gives angle BOX. Then it would be easier to find angle AOB first. The arc length AB is given by 15, and we know that arc length is always given by r theta. That is 15. theta must be in radian. R is 6 here, so 6 theta is 15, and then theta is 15 over 6. That should give you a value of 5 over 2. So you know that theta is 5 over 2, then that angle theta here is angle AOB. That has a value of 5 over 2. Then to find angle BOX, that would be pi minus 5 over 2, which is angle AOB. And angle BOX is 0.642. Now this angle is 0.642. Let's look at this right triangle, triangle OBX. So the opposite over the hypotenuse gives you the sine ratio. Then from triangle BOX, which is a right triangle, the opposite is BX. The hypotenuse is OB, which has a value of 6, and that is given by sine of the angle BOX. So you have sine of 0.642. Then BX is 6 times sine of 0.642. Bx here is 3.591. So you know the length of Bx, which is 3.591. Then the last length that we need to find would be xc. As long as you can find OX, you can find XC. So OX is the adjacent to this angle BOX. We can always use the cosine ratio. It's faster than using the Pythagorean theorem. So from this right triangle, OX, which is the adjacent, over the hypotenuse, that is given by cosine of 0.642, so that OX is 6 times cosine of 0.642, and that should give you a value of 4.805. That is OX. What we want is XC. XC is 6 minus OX. So you have 6 minus 4.805, and that is 1.195. XC, you replace XC with 1.195. Then the perimeter of the shaded region is 8.636 centimeters.